64 times 8, and if I round it to a 60, 60 times 8 equals 480. Remember, I have 1 0. 6 times 8 is 48. That's way too big. So if you're wanting to go and just get an estimation, you can do that to see how close you can get and then multiply it out. There are so many different ways to solve each problem. 3 times 5 is 15. 15 times 9. Well, if I had 9 times 5 is 45. And 9 times 1 is 9 plus 1 is 13, so it's not even large enough. Okay, so I don't have to do all of those if I've already figured it out, but you may want to just double check to save you're okay. All right, I'm going to go ahead and move on. Don't forget that when you're multiplying decimals, you need to move that place value over to the left and how many over to the right. So whatever number of place values you have to the right, at the end on the product, you're going to move it that number of times to the left. So don't forget about that. Let's take a look at number 4. The lengths of 2 dogs are given below. A Labrador is 36 inches and a Poodle is 12 inches. What is the difference? I'm going to circle that word difference. I'm going to put subtract in lengths of the 2 dogs in feet. So now I need to convert. And see how for me, I'm going to do it right away. Convert inches to feet. Did that take any time? No. Some of you are not wanting to rewrite the question into a fill in the blank. Okay, if you don't want to do it, I strongly suggest you do. If you don't, please make those notations in your question so that you can identify. There's always more than one way of doing it, but you know yourself whether you're able to remember what you're doing and know what you're solving for, or if you're just reading through and confusing yourself. So I'm going to put the difference. The difference in lengths of the 2 dogs in feet is blank. Okay? All right. So now I have inches and I'm moving them to feet. Well, again, I'm going to go to, if you don't remember, that's cool, but you're going to have this sheet here. And it's okay. So I have inches to feet. So I know that there's 12 inches to 1 foot. How did I get from 12 to 1? I divided it by that same number. That was my rule. So here I have 36 inches. And remember that when you work backwards, you're going to be multiplying. So what times 12 equals 36? And that's going to be 3 feet. Do the same thing here with the 12. So I'm going to mark it over here that this is 3 feet. I did the 12 inches, which is going to be 1 foot. Then I'm going to take the difference and I'm going to subtract that out. And that leaves me with 2 feet. And the answer is D. Do you see all the work that I've done? You see what's been happening? So make sure that you don't do this part where it's in my head and I don't need to do it. Because it's not in your head. Your brain is in training, so it's learning how to keep things in your head so that you can do it quickly. But for now, write those all down. Don't take any chances. It's not worth gambling what you think you know versus what you are supposed to be solving. All right, let's go to number 5. Number 5 reads, Mr. Reed is planting a vegetable garden with 4 equally sized sections he represented in the diagram. This is equal to this. This is equal to this. Tomatoes is equal to the cucumbers. Okay? What is the total area, Mr. Reed's vegetable garden, in square feet? Remember, I'm going to refer to my handy dandy sheet. For a rectangle, rectangle is area equals length times width. Coming over here, I'm writing down area equals length times width because that's what I need to solve for. All right, so we need the total area. Well, if this is 4 feet, and I know that they're all equal sizes because it told me they're 4 equal-sized sections. This is 4 feet. If this is 3 feet, then this is 3 feet. So now I need to add these 4 feet plus 4 feet. And so this whole part right here is 8 feet long. This section here, add those together, it's 6 feet long. So my length is 8, my width is 6, and so my area is equal to 48 square feet. Now remember, when it says square feet, you're looking for area because there's how many squares. So there's going to be 48 squares that fit in this area. Okay, so the next thing, number 6. A square has a perimeter of 12 centimeters. Perimeter. Perimeter, I'm going to put add all sides. Helps me remember. And an area, I'm going to put length times width of 9 square centimeters. And it's a square. And a square has all equal sides. Okay? They're all congruent. We're going to use the ruler provided. This is the ruler that they're talking about. One side has centimeters. The other side is inches. So you're going to be using this ruler. It says use the ruler provided to measure the line segments below to the nearest centimeter. Which line segment could represent a side length of a square with these measurements? All right, so I'm going to draw out a square. I'm going to put P equals 12 because I need to find out this one, this one, this one, and this one. The area equals 9. All right, well, guess what? If the area is length times width, what times what equals 9? You're right. 3 times 3 equals 9. If I were to add all these up, 3 plus 3 plus 3 plus 3, what do I get? So I have 12 equals 3 plus 3 plus 3 plus 3, and it equals 12. I have 4 times 12 equals 12. 4 times 12. What did I say? 4 times 3 equals 12. Sorry about that. Okay, so I need to come up with, so each side is 3 centimeters. So I'm going to use my centimeter side, and then I'm going to get the closest to. So I'm looking at this one here. As a matter of fact, I can just put this upside down too. That's easier for you. Depending on which one. If this is easiest for you when you're measuring, that's fine. If this is easier for you when you're measuring, that's fine too. So you're going to go from this point here to this point here. It's close. So if you can see, it's just a little bit over. So I'm going to put a question mark there. I'm looking at this one. Oh, that's way too big. I feel like it's Goldilocks like the other one last night. All right, and that's way too big. And this one right here is, oh my gosh, it's way too small. This looks like it's a little bit about 1.5 centimeters. So the A is the one that is closest to the 3. All right, you see the work that we did? Make sure that you're doing the same thing. Find the ways that are going to help you remember and do it. Every strategy is different for every person. Some work the same with others, some don't. So what works for you, stick to it. A set of ordered pairs are shown in the graph below. Which table represents these ordered pairs? All right, so if you're that kid that has to circle your X and your Y so that you know you walk across, or that you have to put this first, and then this if you need to mark it second, so you know what to do. Or if you're needing X and then Y, so you know what needs to be done. Mark it the way you're going to remember. Okay, so which table represents the ordered pair? I'm going to my X. I need to walk across 1, 2. What's here? Nope, so this is not going to work. Next one, 2, 1.5. No, because it would have been here. So that doesn't work. 2, 1, this works. 3, 2. So I'm going to actually, like I did last night, draw this across so I can see it. 3, 2, this works. Okay, and if you're needing help, this is your X and this is your Y. So if you get confused and you have a problem that's already marking your X and your Y, go back and use that as a reference on all your other problems, okay? All right, so now the next one is going to be 4. So I did this one and then this one. Next one is 4, 3. So I'm going up to my 4. I'm going to cross to my 3. That's right. 5, 4. That's right. And 6, 5. Oops. And that's right. Okay, so I have a strong possibility. 2, 1. Well, that was right. 3, 2. That one is right. But look at this one. It's 4, 4, but that was 4, 3. So that's not right. So my answer is C. So I did all this work to prove what to prove my work to be, make sure that it is correct. All right, next problem, number 8. Number 8, the ordered pairs below represent 3 places. And here we go, just like we did last night with the map. The playground is at 1, 3. The softball field, you're going to find it at coordinates 5, 4. And the tennis courts at coordinates 4, 2. Again, I'm going to mark this X and Y, X and Y, X and Y. I'm going to mark this X and I'm going to mark this Y. So I'm going to go here first. Then I'm going to do this one second. It's going to help me remember. So if it's going to help you remember, you do the same thing too. So the 4th location, the swimming pool, is located at 1, 4. So I'm going to find my 1, start to the X over 1, and I'm going up to 4. I'm going to go ahead and plot the rest of them. So I'm going to write swimming pool here. Okay, next one is 1, 3. This is playground. Next one is 5. I'm going over on my x-axis. 4. Softball field. And the next one is tennis courts. 4, 2. This is tennis courts. All right, so now let's look at the first one. We're saying that the swimming pool is located 1 unit to the east, and remember your compass rose, and 0 units north of the playground. So I'm going to circle my playgrounds because that's where I'm going. Is my swimming pool located 1 unit to the east and 0 units north, which means that that's where it's going to stay? Nope, that's not a true statement. All right, so let's look at this next one. The swimming pool is located 4 units east and 1 unit north of the softball field. Well, let's go to the softball field. I'm over here. So I'm going to go 4 units east. And now I'm off the grid. So that doesn't work out because I have to go in the direction of of what my compass rose tells me. So I have to go in the east direction. All right, letter C. The swimming pool is located 3 units west and 2 units north of the tennis courts. All right, so I need to go to the tennis courts right here. And I'm going to go 3 units west. West, I'm going to go to the left. So this is 1 unit, 2 units, 3 units. And I'm going to go 2 units north where I'm going up. 1 unit, 2 units. Oh my gosh,